Hello everyone, good morning. I welcome you all for the yet another technical session for Automatus 2020. This is our third company which we are tied up with, that is Allied Electronics. Today we have Sunish Suresh with us. Sir is graduated in Electrical and Electronics from Kerala. He is right now working with the Allied Electronics. He is well versed with the PLCs like Siemens, ABB, etc. As well as he is well versed with the SCADA systems. He is working right now in a different projects like water treatment plant, pharmaceutical company, dryer products, etc. He is also having a wonderful experience in IIoT. Now I request sir to start with the PLC session. Thank you.
A very warm welcome to everyone. Today I'm going to talk about Zelio Smart Relay PLC and the programming software that is the Zeliosoft. Before starting with the session, I would like to introduce myself. I'm Sunish Suresh and I've been working for Allied Electricals as automation project engineer for quite some years now. Here at Allied Electricals, we do complete automation, that is from panel fabrication, wiring, testing of the panels. We do programming for process automation as well as machine automation systems. We are also into BMS and we do provide complete solution for IIoT. We are serving the automation industry for last 20 years and we are authorized dealers for Helmholtz, Omron and Cierto, and we are system integrator for Wonderware. So this was about me and Allied Electricals. So let's just move on to the presentation. So before getting into the Zelio logic, let us see what exactly a PLC is. A programmable logic controller in a broader sense is just a collection of multiple switches that is being controlled by a program which is fed into the PLC memory. Along with this, it has some additional features such as computing, sensing, generating digital as well as analog signals. So a conventional microcontroller such as Arduino can also perform this kind of tasks. So what exactly make a PLC different from a microcontroller then? Well, the most basic difference is the build. The PLC are very rugged and robust and it can withstand the harsh and industrial environment such as extreme temperature, pressure change, humidity and dust. And the PLC also comes with built-in protection for surge, overcurrent and also power failure protection. And apart from this, the programming of a PLC is much simpler and faster than programming a microcontroller. And all this reason actually makes a PLC a very ideal choice for industrial application. Coming to the capabilities of the PLCs are capable of performing various logical operations. It has timer, counter, it can generate analog signals, it has PID control as well as arithmetic function. The PLC also supports various communication protocol such as TCP/IP, Modbus, serial communication, OPC, etc. Also, the PLC can be connected to an HMI for better operational control. And the PLC also has a real-time function, that is the RTC. So coming to the advantages, the first one is reduced space. So before the PLC, a lot of logical operations were done by using relay logic, and this used to take quite a lot of space in the panel and this used to make the system very janky. So using a PLC has definitely reduced the size of the overall panel. The second one is energy efficient. The PLC consumes a very low power, so they are very energy efficient. It is easy to maintain. PLC are economical as compared to the hardware relay logics. It is very flexible as changing a bad PLC doesn't require much effort. Also, it has shortened the project time, as programming a PLC doesn't take much time as compared to manually wire a hardwired relay logic. And as said before, the build of the PLC is very rugged and robust. So these are the advantages of using a PLC. Next is the basic architecture of the PLC. The PLC consists of a CPU, program memory, input module and an output module. Here you can see that the PLC is connected to the process of the machine by some field inputs and control elements. The input module is been fed with the field inputs, whereas the output module controls the control element of the machine. The program is being stored in the PLC memory, and the CPU computes that program to perform the desired task. And also there is a power supply to power the PLC. Coming to the Zeliosoft, the Zeliosoft PLC are mostly used in small scale application. As the name suggests, the output of the PLC is of relay type. There are various extensions available, such as digital I/O cards, memory cartridges, communication modules such as Bluetooth interface module, GSM module, Ethernet module, and the software which is used to program this PLC is called Zeliosoft. Next is the types of Zeliosoft PLC. Well, there are two types of Zeliosoft PLCs. The first one is a compact type. The compact type comes with LCD or without LCD variant. Well, the second one, that is the modular type, comes with a provision for adding additional I/O cards or communication modules. So these are the two types of the PLCs. So about the programming software Zeliosoft, depending on the model which you choose, you have two options to program the PLC. You can either program it in ladder or FPD. The second thing is that the PLC only has a single subroutine, that is your main subroutine, and the length of this subroutine is about 120 to 240 rungs. That depends upon the model which you choose. And also the program has a built-in simulation, so you can simulate your program within the software itself, so you don't need a PLC for that. And also other features such as monitoring and supervision are also available. These are some of the common notations which is used in the Zeliosoft software. The first one is a input contact, and it is denoted by letter I, and it has a symbol of a switch. Next we have auxiliary relays. It is denoted by letter M. These are the memory variables which can be used internally inside the program. It doesn't have any physical input or output. Next we have the output coil. It is denoted by letter Q, and it has a symbol of a coil. Next we have timer T, counters, clock functions, text function blocks. The timer and the counter functions are similar to other PLC, while the clock is a function in which you can schedule certain tasks based on the real-time clock of the PLC. Next is the text function block. Since the PLC has a on-built LCD display to it, so you can show certain text on some trigger. So I will be talking about this in detail when we will start doing the software simulation part. Next is the application of the Zeliosoft PLCs. As I said before, the Zeliosoft PLC are used in small scale applications. Some of the applications are production assembly and packaging, agriculture applications such as pumping, irrigation, etc., warehouse lighting systems, compressor and air conditioning systems, the HVAC system that is used in the BMS system. Next is a PET blowing system, conveyor system, textile, plastic, material processing, etc. So this was the end of the PPT part. Next we will be looking into the programming software. So before getting into the software, I will like to show you how to download the Zeliosoft. So just open up a browser and type Zeliosoft. So you will find a link for the software by Schneider Electric India. So just click on the link and you will be directed to the website. In the website you will find a programming software link. Here it is, programming software Zeliosoft 2 multilingual. After clicking the link, it will get you to the software page. So when you scroll down, you will find some tabs. In that tabs there is a tab for software and firmware. So after getting into the tab, you will find a Zeliosoft version 5.3 programming software and documentation. So this is a zip file and it is about 144 MB. When you click it, the download gets started. So I will just cancel it as I have already installed the software, and so the installation procedure is pretty simple. Okay, so this is how you download the software. So after the installation has been completed, you will get to see an icon like this, Zeliosoft 2. So to open the software, just double click on this icon. So once the program has opened up, you will get to see some options like this. You can register the program, or you can create a new program, you can open an existing program, you can open a recently used program. You can download a program from a module or a PLC. You can also go into the monitoring mode into the PLC. So these two options are only available when you have a physical PLC connected to this software. So, and lastly you have the exit button. So I will go ahead and just choose create a new program. You will get to see a module selection page like this. So in this you have 6 categories and you can just hover your mouse over each category to know what is about. So the first one, like you can see that it has 10 to 12 IO without extension. By extension I mean that you cannot add extra IO cards to it. So these are the compact type one, and the with extensions are the modular ones. So this one has 10 to 12 IO, and this doesn't have the screen. So this is 10 to 12 IO without the screen and without the extension one. This has the screen but doesn't support the extension. It has 20 IOs. So this category has 20 IOs without the screen and without the extension. These two are with extension one. This one has 10 IOs and this one has 20 IOs. So if you select any one category, you will get to see the PLC option or the modules which are available in that category. So you will get to see its power supply configuration, and you will get to know the total number of IOs, that is the input and output, also whether it has analog input or not. You will get to see whether it has screen or the keyboard, that is the navigation button, onto it or not. and also you get to see whether it supports the clock function. That is, as I said in the PPT, that clock function is nothing but you can just schedule some tasks depending upon your date time, that is your RTC. And also you get to see what programming language it supports. So the first one only supports the ladder logic, whereas the last 4 supports both ladder as well as the FPD. So the last column is just a reference, that is the model number. So I will go ahead, and also in each category you will get a bunch of options. So based on your application you can choose any one of them. So I will go ahead and choose a random one. I will just go with this 24 VDC, 4 discrete, 4 digital, the discrete and analog input. So it has both the language and as well as the clock function. So I will go and click onto the next button. So after clicking next, you will get one more page. So in this page you can see if you want to add a communication module, you can add. This is not an IO card, since this module which I have selected is not a modular type, it is a compact, so you cannot add additional IO card to it. I will just leave like this, and I will click on next. So in the next page you will get to select the programming type. You can choose the ladder or the FPD. I will just go and choose the ladder, and I will just click on next. So this is the overall look of the software. You have some options in the header side. You have a body which contains the editor section. In this you can write your program in ladder. In the footer side you will get to see all the variables which the PLC supports. So in this you have some inputs, that is the physical input which is denoted by I, and you have the 4 keys, the navigation keys. Then you got the variable, that is a memory variable. So this PLC supports up to 56 variables. Then you got the PLC output, that is the 4 output, and then you have the timer. This PLC supports 28 timers. It has around 28 counters. It has one fast counter. The use of fast counter is to count a frequency pulse up to 1 kilohertz. That means if you have a fast input and you want to count the pulses, you can use this fast counter. So this PLC supports only one fast counter. And then you have the counter comparator. That means if you want to compare 2 counters, you can use this comparator function. Then you got the analog comparator, and this is just same as that of the counter comparator. It just compares 2 analog inputs. So it can be analog or it can be any variable number. So you can compare 2 analog values with this function. And then you got the clock function. So this PLC supports around 8 clock function. That means you can schedule 8 tasks according to the real time. Then next you have the LCD block. So you can use this function to show any text onto the LCD screen, as this PLC supports, as this PLC has the LCD screen. So you can use this function to show any text onto the screen. Next you have the LCD backlighting. So you can use this contact to enable or disable the backlight of the LCD screen. And next you have the summer winter function. So basically this is also a contact which can be used to know the state of this summer winter function. So the state actually changes with the season. You can change the timeline, the time zone of the season in the program configuration. I will be showing all of this in detail in the later section. So this was about the footer section of the software. Then you got the header section, in which you have various tabs available. You have the file tab, in which you can open, close, you can save the program. Then you got the edit tab, in which you can insert a line, you can delete line, you can go into various entry, you can say. Right now it is in the ladder entry, that means it is in this programming section. You can go into the Zelio entry, which just shows the current state of the LCD screen. You can go back to the ladder entry by using this button. You can also go to this configuration. Basically this tab just shows the current configured timer as well as a counter which is used in this program. And you got the text entry. This page just gives you option to add comments, or you can say tags, to each and every variable available in the module. So I will go back to the ladder entry. So this was about the edit tab. Then you got the mode tab. So right now it is in the editing mode. You can go to the simulation mode. Also you can go to the monitoring mode. So if you want to use the monitoring mode, you need to have a PLC connected to this software. Yes, and also you can change the mode by using this shortcut keys. So as you can see, it is in the edit mode, and then you got the simulation mode. And also you can see the monitoring mode button doesn't work because you don't have a PLC connected to this software. So I will go back to the editing mode. Then you got the module tab, in which you can change the programming type. You can also go to the diagnostics. You can set the clock, you can update module firmware, and also you can change the program, the module language. You can see there are 6 options available for language. And you got the Zelio communication tab. Then you have the transfer tab, in which you can transfer the program from PC to the module, that is from PC to the PLC, which is just download. Then you can upload the program from module to the PC. Then you have various other options, run, stop. You can compare is in the software with the PLC. You can also clear the program, and then you got the various communication configuration here. Then you have the option tab, in which you can modify the colors. So you have various options to change So first you have the active color. So when you have a energized contact or a coil, so it will show in red color. When it is in inactive state, so it will show in this purple bluish color. Then you got the edit color, or you may say the addition color. So right now this program is in edit mode, so you can see that each line or each wire is other option. Like you can change the force value colors. You can also change the background of this edit window. So I will just keep it in default mode. Then you got the display option. You can choose to show the ladder symbol or the electrical symbols. Then you have the directory window and directory tab, as well as the window tab. And here you got the help menu. So I will recommend you to go through this help tab if you are stuck anywhere in this software, because they have nicely documented each and every section of the software. So I will recommend you to go through this once. You have some shortcut keys available here. You have a program consistency option, program consistency button. So if I click on it, it shows NTR. That means it doesn't have any error right now. So if I just place a random wire, you can see it changes its color to red. So if I click on it, it will show some errors. So it has around 4 errors. So if I just clear all the errors, it will show the NTR. That means it doesn't have any error right now. So you got the help button here. You can also change the zoom option of the window. So this was about the header section of this software. So next you have the body section of the software, that is the middle part of the software. So in this you have 4 options. You can go to the Zelio entry. So as I said before, this shows the current state of the LCD screen. Then you have the ladder entry, so in which you do the programming part. So in this you can see it has around 7 columns including the comment column. So you can add around 5 contact in each row, and you can add 1 coil, and you have a total of around 240 rows, and also you can see the current state of the row using this indicator. So this was about the ladder entry. Next you have the configuration page. So in this you can see all the configured timers, counters and variables in this current sheet. I will explain this in the later part. Next you have the text entry. So this acts as a tag page in which you can add comment or tag to each variables of the PLC. So I will just go back to the ladder entry and I will explain you with a simple program here. So I will just go and add an input. So the input is of the type NO. You can change it to NC by right clicking on it. You can change it to NC. Right now I will go back to NO, and you have the coil, and that is the discrete output. So you can choose any of the coil type. You have 4 options here. You have the active on one. You can choose the active rise in edge one. There is the set and reset option. So I will go ahead and choose this active on, and I will press it and I will drag it to the coil section. As you can see, if I try to place in the contact section, it won't allow me. So I will go ahead and place it in the coil section. Right now I haven't connected the contact with the coil. So you can see there is a program consistency which is showing in red color. So if I click on it, it will show the corresponding errors. So if I connect the contact with the coil, you can see the it shows the NTR, which represent that there is no more error here. So I will just close it, and I will go to the simulation mode by using this button. In the simulation mode you have 4 options. You can pause or run the simulation. You can mimic a power failure. You have the run button and you have the stop button. If I click on the run button, you see the simulation has started here, and you see the color of the program changes to its off state, which is the purple blue color. If I click on it, it will change the color to red state, which shows that the coil is energized. So you can activate the contact by clicking on it, or you can use this use this input tab, as well as you have the output tab as well. So you can use this also. So this shows up visual representation of the switches as well as the output. So I will just stop this simulation. I will go back to edit mode and I will explain you with some more examples. So just change the name to this switch 1 and I will add some more names here. Switch 2, sorry, switch 2, switch set and switch reset, and we'll add some more coils. This will be bulb 2, this will be bulb 3. Okay, so I will add I2 here, and below I will add a bulb 2. Okay, I will choose this active on impulse relay edge, that is the rising edge. It will detect a rise in the edge of the contact. So I will just connect the coil with the contact. Next I will add the set switch. So we'll add the set switch, and here is the reset switch. I will add bulb 3 here to the set state, and the bulb 3 here in the reset state. Okay, so I will connect every coil with the contact, and I will go to the simulation mode and I will just run the simulation. Let me just adjust the tabs here. Okay, the first one is pretty simple, which we just saw before. If the switch is in on state, it will output the coil. When I switch off the switch, it will turn off the coil. The next one is the impulse type, which detects a rising edge. So if I switch on the I2 switch, it will energize the coil, and it will stay in that high state till a rising edge is not detected again. So if I again press the I2 switch, so the coil 2, that is Q2, go back to its off state. I'll just show again, so you can see. Next is the I3 and I4, which is the I3. I will be using it as the set switch for Q3, and I4 I will be using it as the reset switch for Q3. So I will just switch I3 on, so it will set the Q3, and the Q3 will stay latched unless I have reset it using the I4 switch. So even if you press I3 switch many times, it won't affect the state of the Q3, as it has already gone to its latch state. So I will just unlatch it by using the I4, that is the reset switch. So basically this example was about the different type of coils available in the Zeliosoft. I will just go back to edit mode. So next I will show you about the M variable, that is auxiliary relays. These are the internal variables. They doesn't have any input or physical output. So they act same as that of the coil and the contact. So I will just show one example with auxiliary relays. I will just delete these. I will place this contact coil here, and I will choose a M1 relay, and I will use the M1 contact here. So basically what will do is the switch I1 will energize the M1 coil, and when the M1 coil is energized, the M1 contact will switch on the Q1. I will go to the simulation. I will run the simulation and I will just switch on. So as you can see, it's indirectly switching on the bulb. So this was about the memory variable, that is the auxiliary switch, auxiliary relay. So I will go back to the edit mode. Let me just clear. Okay, so next I will show you an example about the timer. So if you go to the timer, in this module you have around 28 timers. So starting from T1 to TV, you have around 28 timers, and each timer has a contact T, which has a command, that is a coil, and then you have a reset timer. I will just select T and I will place in the coil section, and I will just add a switch I1. I will just connect the switch with the timer, and next I will add a T1 contact here, and I will just place a output coil here. Let me just connect it. So I will go to the simulation mode, and as you can see, there is one more tab available here, that is a monitor mode. So in this you can see the preset and your current time that is configured here, and also you can go to the configuration tab. So right now it is not available because I am not in the edit mode. I will show you that in the later section. So if I just click on this, so I haven't done the simulation. If I just click on it, you can see it directly turns on the bulb. The reason is that I haven't set the preset time. So I'll go back to the edit mode and I will just configure the timer. As you can see, there are a bunch of configuration available. So you have a function A, that is a normal on delay timer. You have a function small a, that is you have to press to start the timer, and you have to again stop it. So the timer starts by having a delay, and it will stay in the high state unless you had reset the timer. Then you have function A, that is off delay. So the timer will goes to the high state, and after a delay that is been set, will go back to its normal state, that is its low state. I will just choose function A for this example, and I will just set the timer to 3 seconds. And also we have various units available here. You have small s, just show the resolution. So you have 1/100 of a second here, and you have the big S, that is also a second, which shows 1/10th of a second. That is, we can set the resolution to 1/10th of a second. So I will just choose the smallest, and I will just type 3. It shows that the timer has a preset value of 3 seconds. I will just press OK, and I will go back to the simulation mode. Okay, I will bring back the output tab. We'll run the simulation. After pressing the switch button, you can see the output coil close after 3 seconds. So just switch off now. You can see again the current time it increases and it goes to 3 seconds. Then the output coil energized by the timer output. So this was about the timer example. So you can Let's go back to the edit mode. You can also see the configuration available in the configuration tab here. So I have a timer configured here with a preset value of 3 seconds. So you can see what type of a timer is used, and all in the configuration tab. Go back to ladder entry. As I said earlier, there are a bunch of options available. You can just go through each option. You can see this is just a off-period timer. You have a one-shot timer as well. So it just requires one pulse and the timer gets start. The timer goes to its low state after a delay. And you have the timing after pulse. That is when the pulse goes down. That is when it detects a negative edge. It will start the timer, and after that delay it will go back to its low state. And you have a symmetrical flashing, that is the timer coil is energized, so it will to a high state. The timer will have a on and off state depending upon what preset you have set here, and it will go back to off state when the contact goes off. I will just show an example of this here. So I will just go to bit more. I will just choose this option here, and I will just go and place 1 second. I will just choose 1 second here, and I will just press OK. I will go to simulation tab. I will press button 1. Sorry, I forgot to run the simulation. We can see it will change the Q1 state to on and off, and the on and off state changes in every 1 second, as I have set the preset to 1 second. So this was about timer. You can learn more about the timer using the help menu also, or you can just go through this options here. There are different timer type available, so you can just go and refer this. Also you can go and refer the help menu here. Just search for timer here, and you will get to see all about the timer, each and every type of timer, what all options you have available. So this was about timer. So next is the counter. I will just go to counter. So you can see there are in total of 28 counters available in this module. So the same like the timer, you have a counter contact, you have some bunch of coils here. You have the counting coil, you have a direction coil, that is, it decides the direction of counting, where either you can count up or count down, and you have a reset button or the initialization. So if you use this, you can just initialize a counter to 0. So I will just add a counter here. So I will delete the timer, and I will just place a counter instead of the timer. And we'll just double click on the timer, and as you can see there are two options available. Either you can select the first one, which is it set value to 5, so the output will get on when there is a total of 5 pulses detected at the counter end. And you can also choose the second one, which is it outputs on when the value reaches 0. So I will just choose the first one, and I will press OK, and I will just choose the counter contact here, C1. So okay, I will just simulate the program, and I will add the input tabs here. So with the output tab here and a monitor tab. Just adjust the tab so that it can be visible. So I will just run the simulation, and you can see the configuration. I have set the preset value of the counter to 5, and right now the current value of the counter is 0. So this press once the time the input, you can see the current value of the counter has changed to 1. I will just press for about 5. Okay, so you can see it has detected a total pulse count of 5, so it has turned on its output. So if I press once again, you can see the counter value goes up as the preset value has reached the current value. The current value has reached the preset value, that is 5. So the output stays on. So as you can see, I cannot reset the counter as I haven't used the reset one. I will just add the reset coil also. So I will just add one more switch here, that is switch 2, and I will use this switch to reset the counter. Let me just connect it. I will go back to the simulation board, and I will just give it that. As you can see, the current value is turned to 0 as I have initialized the module using this run button. So I will press this. Yes, as you can see, the current value has crossed the preset value and it has turned the coil to high state. So I will just use this switch 2 to initialize the counter. As you can see, I have reset the counter here using the switch 2. So again, I will go back to edit mode and I will just show the direction option. I will add switch 3. I'll just connect the switch 3, that is I3, with the down counter option. I will just change its name to switch 3 for simplicity. As you can see, this will change the direction of the counter, that is the C1. I will go to the simulation mode and I will run the simulation. Okay, so I have pressed the switch I1 for 4 times and it has detected 4 counts. So I will press it once again and it has crossed the preset value. Now I will just use this I3 switch to change the direction of the counter. So if I press once again, as you can see, it will now count down. So using this direction coil, you can change the counting direction, that is, you can either count up or you can count down. So if I just remove the I3 switch, it will go back to normal counting, that is, it will count again. So as you can see, once again it is counting in the upward direction. So this was all about this counter. So I will just stop the simulation. I will go back to the simulation edit mode. As you can see here, there is one more counter option available, that is the fast counter. Actually, this counter is used when you have a very high speed input. So as I don't have a physical high speed input available here, so this will just act as a simple contact here and counter here. I just gave one here and sorry, just clear this. I will add the Q1 to configure. So you can see this has the same option just like the normal counter, but you have an extra option here. You can set the frequency, like the maximum frequency of the pulses that has to be detected here. So if I just reset the value to 5 and I just pressed OK, I will go back to the simulation mode and I'll just run the simulation and we'll just add. Okay, I3, I press the I3 button. So as you can see, it does nothing as this is a high speed counter. So as I said, this can be simulated in this using the simulation mode. So you have to have an actual PLC connected to this. So we'll go back to edit mode. So this was all about the counters available. Also, if you want to learn about the counter, we can go to the help menu and we can just go through the counter section. So next I will show you an example of a counter comparator. As you can see, there is a total of 8 comparators available. So just choose in comparator here V1. If you double click on the comparator, you can see some options here. You have a expression tab available here, and you have some comparison operator. So what basically a counter comparator does is that it compares two counters. So you have CX and CY, and you can just set this counter to any you can set the CX to any counter here. Also you can just change it to a constant value, that is you can just play around this value and you can just give it a constant value. So I will just get two counters, C1 and C2, and I will just for the simplicity I will just choose the equal to 1 and press OK. For this example I will add two counters here, that is C1 and C2. For the counter input I will add two switches, that is I1 and I2, and I will just connect it to the corresponding counters. Okay, so basically for now the expression is that if the C1 values equals the C2 value, then the V1 will output a high signal. So I have set the preset of the C1 to 5 and C2 to around 8. It doesn't matter, because for this example we just need the counters to be the counter values to be equal, that is the current value of the counter to be equal, so that the V1 outputs a value. Just to see the output, I will just add a output coil, that is our Q1, and I will just connect the V1 with the Q1, and I will go to the simulation mode and I will just run this program and just bring back the input, and here is the output, and you can also see the monitor tab here. So as you can see, the V1 outputs a high signal, since the value of the C1 and C2 for now it is both the values are 0, so it satisfies our equation since both the values are 0. So C1 equals C1 equals C2. So if I just give a pulse to C1, as you can see the current value of the C1 goes to 1, and the equation it doesn't satisfy the equation, so it doesn't give an output here. And if I give an input to C2, as you can see both the current value of the counters are 1, so it satisfies the equation and it outputs high state. So again, if I just keep on increasing the value, it won't satisfy the equation. So output of the comparator is 0. So if I just go back to edit mode, and if I just change the C1 to a constant here, if you don't want to compare a counter with another counter, you can just compare it with a value. So if I just change the CX value to 5, and if I just choose greater one, if the C2 value is less than 5, then the V1 will give an output. I will go back to the simulation mode. As you can see, the value of the C2 is 0. If I increase the value, okay, sorry, I am done the simulation here. So if I just give a input here, you can see that the V1 value is in the high state, since we have equation for C2 that if the value of the C2 is less than 5, then it will give the output V1. So if I just increase the value of C1 to 5, so you can see the equation doesn't satisfy anymore, and the V1 outputs a 0 value. So this was about counter comparators. So next we will talk about the analog comparators. So basically the analog comparator is same as that of the counter comparator. The difference is that it compares two analog inputs or two analog values. So if I just go ahead and add a analog comparator here, if you double click on the analog comparator, you can see the same option as that of the counter comparator. The only difference is that you can now set the value 1 here as a reference value, that is a constant value, or you can change it to any analog input here. So I will just choose this as IB, and I will keep the analog value 2 as a reference value, that is 5. And if you see, so the expression now tells that if the value of IB is less than 5, then the equation satisfies, so the A1 will give an output. So I will just change it to this greater than. If the value of IB is greater than 5, then the A1 will give output. So we'll just add a coil here. I will just connect both the ends. Go to simulation mode. I just run the simulation. As you can see, there is one more tab available. This helps you to simulate the analog values and get the discrete output as well. So right now the equation doesn't satisfy, as you can see in the monitor mode also. The equation is IB greater than 5.0. So this tab, so the value of the IB should be greater than 5, so as to get the A1 contact to a high state. So if I increase the value of IB over the constant value 5, so you can see the A1 contact goes to a high state, and it energizes the coil Q1. So this is about the analog comparator. In this example, I have chosen the value to be a reference value. You can compare to analog value as well. So that is analog input value as well. So I will just go into the edit mode, and I will just change the value to a different input, that is IC, and this time I will just keep we'll get this equal expression. So right now the equation says that if IB equals IC, then the A1 outputs a high state. So if I go back to the simulation mode, so now you can see there are two knobs available. One represents the IB value and the other represents IC. So let me just get this. Right now you can see both the value is 0, so the equation satisfies, and it outputs a value. So if I just, okay, I haven't run the simulation, so yes, you can see the Q1 is in the on state. So if I just increase the value of IB just to make both the values different, so you can see now the A1 contact is in the low state as the equation is not satisfied. So if I just get this value to 0.7, as you can see both the values same, the A1 contact now puts a value since the equation is now satisfied. So this is all about the analog comparators. So if you want to learn more about this, you can just go through the help menu. So next is about the clock function. As I mentioned before, clock function are used to trigger a certain task or a certain program. If you want to schedule something, some program based on your real time, so you can use this clock function. So I will just show you a clock example. Also, in this model you can see there is a total of 8 clock available. So I will just choose one of the clock. If I just double click on it, you can see a configuration tab. Basically there are 4 channels available, channel A, channel B, channel C and channel D. If you want to know more about the channel, I will just open a help menu here just to show that what is the channel about. So yes, you can see there are 4 operating ranges, that is channel A, channel B and channel C. The channel A has a time range of every that is the program can be executed on every day from Monday to Friday, and the start time is 8 and the end time is 18, that is 6 p.m. And you have a channel B which is day and night, every day from Tuesday to Thursday. It starts at 22, that is 10 p.m. and ends the following day as at 6 p.m. Sorry, the 6 a.m. So like that you have channel C and channel D. So if you want to learn more about this, you can just go through this help menu. I will just show a simple example using the channel A configuration. So I will just double click on it and I've just chosen the day, that is Thursday, that is right now the time is around 11:48. So I have configured the on time from 11 p.m. The 11 a.m. to 11:30 a.m. I will just change it to 12:30. Channel B, channel C and channel D I have kept it around same, and I will just click on OK, and I will get a output coil here. I will go to the simulation tab and get this. Okay, I will just run the simulation, and you can see right now it satisfies the time equation. So the contact C1, that is the clock 1, outputs a high state. So you can use this to trigger or excite a program based on the real time. Just go to the edit mode and I will just change the time to 11:30 as right now the time is 11:50, so the program won't work now. If you just go to the simulation mode and you just run the simulation, you can see it doesn't give a high state, so it is in the off state since the time has passed. So like this you can use this clock function to trigger certain task based on your requirement. Like you can set a night program, or you can, for example, in agriculture application, if you want to run a pump on certain time on each day, you can use this clock function to trigger that pumping action. So this is all about the clock function. Next we have the text block. So we have around 16 text blocks. So you can use this text block to show some text on any variables onto the LCD screen, that is onto this screen. As you can see right now, I have a single line of code here, that is the clock one. It is showing in H1 is connected to the Q1. And if you want to display any text message, or you want to display a counter value onto the LCD display, so you can use this text block function. I will show you an example here. So I'll just delete this clock function, and I will add a switch. I'll just connect this switch to the text block, and if you double click on the text block, you can just configure the text block to show some values on it. So you can see here, I will just type a basic text as okay, hello world, and just press OK. And also I will get a reset text. So this is used to turn off the text block. I will get another switch to reset the text block. If I go to the simulation mode, if I just run it, so if you want to see the text menu, you can just go here. You can go to the window menu, and you can just select this front panel. So you can see, you can now get to see the front panel as well. If I just click on this, you can see it shows a text message. And if I again, let me just rearrange it. If I just again press the switch to off state, so you can see the text doesn't goes away. So to deactivate the text, you have to reset the text. So I get this. So I have using this switch to deactivate that text, that is hello world. So I just press it, so the text block goes away and it goes to its default text state. So I will go back to the edit mode. Let me just resize it. So this was about the text block. Next we have the LCD backlighting. As I said before, this is a physical property, I mean the physical contact. So you can turn on and off the LCD backlighting if you want to like before, if you want to show a text in a lighted condition, so you can just turn on the LCD backlighting. And another, we have the summer winter contact. So this changes its state depending upon the time zone. That is, in winter it will show its value in off state, and in summer it will show in on state. If you want to know more about this, you can just go through the help menu and you can just type enter, and you can select this. If you read through, if you go through this help menu, you will get to know more about this summer and winter option. So this was all about the Zeliosoft software. I think I have covered all the topics. And if you want to know about each variable in details, you can just go through the help menu. And if you still have any doubts regarding this Zeliosoft, you can just write your doubts in the comment section. So I will just close this session. Before closing, I would like to thank the Vasai College and Deepthi ma'am for inviting us to be a part of Automatus 2020.
Thank you, sir, for practically explaining it. On behalf of Vidyavardhini College of Engineering and Technology, I would like to thank Allied Electronics for extending their support, especially Vagish Nishad, our alumna, and Sunish Suresh, sir. I would also like to thank our management, our principal Dr. Harishwan Kundre, and our HOD Dr. Deepak Gauri, sir, for their continuous guidance and support. I would also like to thank the whole organizing committee for their valuable inputs for the program. Now for the next session, we'll continue on your Telegram group. Kindly join the Telegram group. Thank you.